Hey everybody, this is section 7.2, areas in the planes. And before I go ahead and show you what the new formula is and the new thing that we're going to be doing, let's go ahead and recap what we have been doing up until now with definite integrals. Before I can start though, I need you guys to label your graphs. This is going to be g of x, this curve here, on all three graphs, okay? So I forgot to label them, so it's always good to label which function is which. And the other function is going to be f of x. And we'll use a different color so that it's a little bit easier to see. And we'll go like that. So this is f of x. And this is f of x. And f of x. Alrighty. Now, let's go ahead and take a look at that middle graph. And we're going to look at what the definite integral is between a and b of f of x. Now, the definite integral from a to b of f of x is asking you to find the area between the curve and the x-axis. So if I do that, I would end up with a region that looks something like this. Not in black, though. It would be in orange. It's not letting me undo that either. Let's see if I can erase it. There we go. All right, so it would be this region right here. From there until B, stopping at the x-axis, following the curve, and we'd be looking for that area. Okay? Now, our third graph over there is asking for the definite integral of g of x from a to b. Well, a is here, b is there, and we're following the function g of x. So if I want to find that definite integral, and yes, I realize I sounded like a total dork when I said that, we would be going from a to b, just that little region. Okay? So what do you get if you subtract those two regions? Well, you would get the area between the two of them, and that's the whole purpose of today's lesson. So let's go ahead and define a couple of things here. If I was to look for this area in between A and B of the stuff that's in between the two curves, all I would have to do is subtract the definite integral from a to b of my top function and minus the definite integral of my bottom function. See, this whole region, if I take away just this little chunk in here, which is coincidentally that piece right there, you're going to be left with the stuff in the middle. So that's the whole purpose of today. So let's go ahead and go back up to the top now. If f and g are integrable, and remember that just means that you can take the definite integral. Not working well for me today. They changed a whole bunch of features on my app here, so I'm getting used to it. If f and g are integrable, that means you can take the integral, with f of x greater than g of x during an interval from a to b. Then the area between those two curves can be found by doing the definite integral from a to b of the function that is larger minus the function that is smaller. All of that dx. Okay? And that's what we showed right here. Okay? The definite integral from a to b of f of x minus g of x dx. All that stuff. I know it sounds like a different language, doesn't it? Okay, so this little region is found by doing this chunk minus that little chunk. And that's what this is all about. Okay, it's pretty straightforward. Basically, we are going to look through these step-by-step instructions since I know you like instructions. You are just going to graph the curves if you need a visual for looking at which is going to be the upper curve and the lower curve. You need to know your limits of integration, so your a and your b. Sometimes they'll be told to you, sometimes you have to find them for yourself. Write a formula for f of x minus g of x, and simplify if possible. If you have to do the integral by hand, that will help. And then integrate. Okay, those are the steps. All right, so step 1, example 1, no calculator for this problem. Find the area between f of x equals 4 minus x squared. So we'll just say that we'll let him be the yellow guy today. And then g of x wants to be green. Go Packers. Okay, negative x plus 2. So I'm going to go ahead and highlight this with my different colors. If you want to just label it, that would be fine. This would be g of x. And f of x is the parabola. Okay, you should know how to graph these things by hand without your calculators. Okay, just a reminder that x squared is parabolic in shape. This is minus, which means it's going to be reflected upside down. And this is a positive 4, so it's going to shift up by 4. That's where we're getting that from. And the negative x plus 2 is self-explanatory. All right, so find the area between these two things. Between x equals 0 and x equals 2. So that's important to note. We could mess up if we don't realize that we're only talking about x equals 0 to x equals 2. So they're already actually telling us our bounds from 0 until 2. And so if we're looking for the area, we are going to highlight this little region right in, if I can pick it, here. In between 0 and 2, bounded above by f of x and below by g of x. Okay, and it just so happens that my f of x was on top and g of x was on the bottom. It won't always turn out that way. So that's what we're looking for. So step 1 is to sketch, wow. Step 1 is to sketch the graph. Done. Step 2 is to find the bounds. And again, that was actually already given to us, so that's easy. A equals 0, B equals 2. Step number 3 is to create a formula for the top function minus the bottom function, okay? Our ceiling minus our floor, I like to say. So top minus bottom. Okay, our top function is f of x. In this case, our bottom function is g of x. And what I mean by top minus bottom is in the region that we're looking for that's shaded, which function is on the top of that shaded part and which function is on the bottom of the shaded part. Okay, so if you have any questions on that, make sure you bring it up in class tomorrow because knowing which function is the top and which one's the bottom is very important. Okay. Because this is a no calculator problem, you're going to want to simplify this formula before you integrate. It's just going to make your life a little bit easier. So for the top function, we've got that 4 minus x squared. For the bottom function, parentheses, don't forget, negative x plus 2. And this is going to simplify negative x squared plus x plus 2. Okay? Step 4 is to integrate. Definite integral from 0 to 2, negative x squared plus x plus 2. All of that is dx. Now we're back to what we were doing before, where we find an antiderivative in order to use our fundamental theorem of calculus. Okay, that's a part that most people tend to forget. So the antiderivative of negative x squared is going to be, remember, raise the power by 1, divide by the new power. So negative x cubed over 3 plus x squared over 2 plus 2x. There is no plus c on this problem because this is a definite integral. So we are evaluating this over the bounds from 0 to 2. Okay, I would expect that you can do this without a calculator on your own. And if you remember the techniques that I showed you when we first learned to do antiderivatives and definite integrals, I told you to leave it in fraction form and combine the common fractions. So if you plug in a 2 first, you're going to have the opposite of 2 cubed over 8, or over 3, pardon me, plus 2 squared over 2, plus 2 times 2. Okay, for this one it ends up really nicely because when you plug in your bottom bound of 0, you're going to be subtracting 0, so that works out well. It's going to be negative 8 thirds plus 4 halves plus 4. Okay, and however you want to simplify this, you will get all the way down to 10/3. Okay, do that on your own and make sure that you can get that fraction. That's huge. Okay? All right, so that's example 1. I'm actually going to have you guys turn to the next page and we'll continue. Big surprise, turn the page. Duh, Miss Edwards. Okay, what's different right now is I'm actually going to have you do a problem on your own so you can pause the video, do whatever you need to do, and I'm actually going to show the solution to this in another video so that we can just keep on moving on here. Okay, let's go ahead and talk about, we can also find the area between two curves that intersect. Okay, so if the bounds aren't given to us here in this problem up here, bounds were given to you, but if they aren't given to you, the points of intersection are going to become our bounds of integration. Wow, my stomach just growled really loud. I hope you couldn't hear that. That's awkward. Okay, so I'm going to show you this next example, and then you're going to try one on your own again. Find the area of the region enclosed by the graphs of f of x equals cosine of x and g of x equals x squared. This is a calculator OK problem. So remember to be in radian mode, and when you do this graph, you'll hopefully end up with something very similar to what I have. This graph right here is my g of x. That's the what's wrong with me? Parabola. This is my f of x. That's my cosine graph, and we're only looking for the area where it's enclosed by these two graphs. Okay, so since the parabola keeps going up and the cosine keeps bouncing back and forth, this is going to be the only region where they intersect, which means this little guy right here, didn't really want to do that in black again, did I? Oh, silly me. There we go. That little region is what I'm looking for. Okay, so first step is to draw the graph. Got it, check. Second step is to find the bounds of intersection. Now I can see quite clearly that that is here and that that is here. Now when you do this on your calculator, you should go at least to 5 decimal places. Find the intersection, and if you have any questions on that, make sure you ask either me or a friend. If we don't have time in class, do it on your own time, but either way you need to know how to do that. I'm getting an A value of negative 0.8241323, etc., etc., etc. And because both of these functions are even, it's going to be symmetric, so my B bounds. Oh, and by the way, let's do let A equal that and let B equal that, and you'll see the beauty of that in just a second. 8241323, etc., etc. All right, so that's step 2. Step 3 is asking you to set up the integral. All right, so I'm going to go from A to B. Well, step 3 was to actually do your top function minus your bottom function. I apologize, but we're going to skip that step for right now. The top function, this is the top of the shaded region, and that corresponds to f of x. And the bottom function is g of x. All of that dx. Now, because f of x is clearly written, g of x is clearly written, and you've identified the a and the b values, okay, this is all the work you need to show me, and you can get an answer now. If you are not sure, you can store these values. If you're not sure on how to store the values, make sure you ask me. Again, this is all calculator stuff that I'm assuming you know how to do. Some of you might not, so make sure you ask about it. But you can store this value into A. You can store that value into B on your calculator. And then when you actually do the integral, use the letters A and B. Okay? When you do that integral on your calculator, you should get a value of 1.095. So press pause, double check it, and come on back. All right. So we're going to move on now to the next slide. All right, this is the example I'm going to have you guys do on your own. So again, do this problem on your own, hit pause, whatever you have to do, but then come on back and we'll finish up the last example. Okie dokie. For this last example, we're going to find the area of the region R in the first quadrant. That's kind of an important word because it's going to limit where we're looking at. Okay? It's bounded above by y equals 9 minus x squared. That's this guy. And it's bounded below by the line y equals x minus 2. Okay, so I'm going to go ahead and shade the region that we're talking about here. That's going to be this region right here. First quadrant only, though. And something kind of interesting just happened, and I don't know if you saw it, but as I was highlighting and as you shade, you're going to see that the shaded region actually has a different bottom function for part of it. So I'm going to show that if I can right now. It's a little bit small, but here's your top function for the shaded region. Notice that it never changes, no big deal. Your bottom function originally is the line y equals 0, and then it changes right there to the line y equals x minus 2. So this is actually two regions. Okay, so I'm going to call this capital A1, and I'm going to call that guy in there capital A2. And we're going to say let R equal those two things added together. Okay, so all we have to do is make a couple of statements that's going to make our lives a little bit easier. So let's take a look at A1 first. For A1, this is a calculator OK problem. I'm just looking at the definite integral. So A1, this is like what we were doing before. This is the area between the curve, y equals 9 minus x squared, and the x-axis. That's no big deal. And that is from 0 up until 2. That's when the line y equals x minus 2 kicks in, if that makes any sense. Okay, so we've got 9 minus x squared dx. Now for the other region, A2, okay, our top function is still that 9 minus x squared, but this time the bottom of the shaded region is the line x minus 2. And all of that dx. Now when it's a calculator OK problem, you don't have to worry about simplifying because your calculator is going to do that for you. Now for region A2, my left bound is 2. That's where the first shaded region left off. But I've got a little problem here. I don't know this location. Okay, it's where the two lines intersect. So let's call that B, and let's find what B is. Okay, B is going to be the intersection between x minus 2 and 9 minus x squared. When you use your calculator, you're going to find out that B equals, that x value is 2.854102. Okay, so that's the B, and because I've clearly stated what B is, I can leave B in my definite integral right there. So if you do both of those definite integrals on your calculators, you're going to get R equals A1 plus A2 and A1 ended up being 46/3, A2 ended up being 2.239, etc. Don't round until the end. For my total region, I'm getting 17.572. All right, and that is it, my dears. So hopefully you tried those other two examples. And we will go over them in class, but I'm going to go ahead and there's another video that is going to have those solutions so that you can double check your work if you want a little bit more of a talk through with it. Okay? Bye. See you next time.